Welcome to the review and preview problems in the CCG book numbers 8-83 to 8-89 with Miss Edwards. 8-83 says, assume figure A and figure B below are similar. Question A says, if the ratio of similarity is 3/4, then what is the ratio of the perimeter of A to B? So the ratio would be, for perimeter, 3/4 as well, because perimeter is a one-dimensional thing. If the perimeter of figure A is P and the linear scale factor is R, what is the perimeter of figure B? Well, we take the perimeter of figure A, we multiply that by our linear square factor of R, so the perimeter of figure B would be P times R. If the area of figure A is A and our linear square factor is R, what is the area of figure B? So we take the area of figure B. When we talk about linear scale factor, we're talking about one-dimensional, but area is two-dimensional. So we need to multiply the area by the linear scale factor squared. So A times R squared would give us the area of figure B. 8-84 says, always a romantic, Maris decided to bake his girlfriend a cookie in the shape of a regular dodecagon, which is a 12-sided polygon, for Valentine's Day. If the edge of the dodecagon is 6 centimeters, what is the area of the top of the cookie? So when we are working with a 12-sided shape, so it's kind of hard to draw, but we know that we're talking about one side is 6 centimeters long. We know that there are 12 triangles because there is 12 sides, so we can take 360, divide that by 12, and we get 30. So my central angle is 30 degrees. So if we're trying to find the area of our entire cookie, we need to find the area of these 12 triangles that make up the inside. So if we draw our triangle, and we said that the whole central angle is 30, we can cut that in half and make 15 degrees. We can also cut our 6 centimeters in half and make it 3 degrees. We can then use our trig to figure out our missing pieces. So we need our height of our triangle. So the tangent of 15 degrees is equal to our adjacent side, our opposite, which is 3, over our adjacent, which is our height. Inverse operations. So 3 divided by the tangent of 15 gives us approximately 11.2. So to find the area of a triangle, we take the base times the height divided by 2. Our base is 6. Our height is 11.2. Divided by 2 would give us the area of our smaller triangle, which would be 33.6 centimeters squared. We then want to multiply that by 12, so we would have a total area of 403.2 centimeters squared of our cookie for Valentine's Day. His girlfriend decided to divide the cookie into 12 congruent pieces. After 9 of the pieces had been eaten, what area of the cookie is left? So what we just did in all this work is we divided it into 12 equal triangles. So if we know how much one triangle is, and we want to know after 9 of the 12 pieces are eaten, so 12 minus 9 leaves us 3. What is the area that's left? We can do 33.6 centimeters squared times 3, which gives us 100.8 centimeters squared left. 8-85 says, as her team was building triangles with linguine, Karen asked for help building a triangle with sides 5, 6, and 1. I don't think that's possible, said her teammate Kelly. Why is this triangle not possible? Change the lengths of one of the sides so that the triangle is possible. So in A, it says, why is the triangle not possible? So if we have a side that is 6 units, and we have another side that is 5 units, and a side that is 1 unit, it is not possible because the two sides, the 5 and the 1, would collapse or be equivalent to the side that is 6 units. So if we changed the length of one of the sides so that the triangle is possible, we can look at this 1 right here, and if we changed that 1 into a 2, 5 plus 2 would give us a greater distance than 6, so it would in fact be possible. So that our triangle could create that vertice above our side that is 6 units long. 8-86 says, what is the 150th term in the sequence? So thinking back to Algebra 1, when we refer to sequences, we have arithmetic sequences, which is adding or subtracting to get to the next term, and we have geometric sequences, which is multiplying to go from one term to the next. The other thing that we need to remember is this term that they give us is always our first term. So when we have a sequence, our 0 term does not really exist, and we cannot plot it on a coordinate plane, but we have to find it in order to write our equation. So we want to look at the pattern of how our sequence is changing, and this sequence is subtracting 1/2 each time, which tells us it's arithmetic. So our sequence, T of n, is going to look very similar to a linear equation. The inverse of subtracting 1/2 is adding, so our 0 term would be 17.5. The 0 term is very similar to the y-intercept, so 17.5. We said that it is subtracting 1/2 each term. So when we plug in, or want to know what is the 150th term, we can replace our n with 150, so negative 1/2 times 150 plus 17.5 gives us our 150th term is negative 57.5. (8-87) said Callie started to prove that the given information in the diagram at the right, then line segment AB is congruent to line segment CD. Copy her flowchart below on your paper and help her by justifying each statement. So when we have AD is parallel to CB, we know that because it's drawn on our picture. So our justification is going to be that that was given to us. We also can see that angle A is congruent to angle C, and our justification is that is also given to us in the diagram. BD is congruent to DB, and we can justify that by saying it's a reflexive property, which we also know as shared side. And then we have angle ADB is congruent to angle CBD. So we know that if we have parallel lines, which is given above, our alternate interior angles are congruent. Then we can prove that triangle ADB is congruent to triangle CBD, and we know that because of angle-angle side congruency theorem. We then can prove that line segment AB is congruent to line segment CD, because anytime we prove that our triangles are congruent, it implies that we have congruent parts, and in this side, more specifically, congruent sides. 8-88, for each pair of triangles below, decide if the triangles are congruent. If the triangles are congruent, state which triangle property proves that the triangles are congruent, and write a congruent statement such as triangle ABC is congruent to triangle blank. Looking at letter A, I have two parallel lines cut by a transversal, so I can state that my alternate interior angles are congruent. I then can state that BC is a shared side with BC, so my triangles are congruent by angle-angle side congruency theorem. And more specifically, I can say that triangle ABC is congruent to triangle DCB. Looking at example B, I know that angle ACB and angle ECD are congruent because they are vertical angles. I am given that B is a right angle and D is a right angle. I'm also given that line segment CD is congruent to line segment BC. So I can state that these triangles are congruent based on angle side angle congruency, and more specifically, I can state that triangle ABC is congruent to, make sure you put the corresponding angles. Our right angle was in the middle, and our vertical angle was last. 8-89 is a multiple choice question. It says, what is the solution to the system of equations below? So remember, you can solve a system using substitution or elimination. I notice that y is already solved, so I can substitute that into my bottom equation. X minus 4 times what y equals 1/2 x minus 4 equals 12. When I multiply fractions, I multiply straight across, so x minus 4 over 2x. Negative times a negative is a positive. 4 over 2 reduces to 2, so x minus 2x plus 16 equals 12. Inverse operation, subtract my 16. I get negative 4 is equal to negative 1x, divide by negative 1. I get x is equal to positive 4. So the only choice where x is equal to positive 4 is letter D. We then want to make sure that our y coordinate is negative 2. You can plug it into either equation. In this case, since my top one is already solved for y, I'm going to take half of 4, which is 2, subtract 4 from 2, and I get y is equal to negative 2. So the ordered pair where these two lines intersect is the point 4, negative 2.